So this is the last part for AC drive. So we will look into the process of braking. So by definition, braking is a process of reducing the speed of an induction motor. In braking, the motor develops a negative torque which opposes the motion of the motor. Induction motor braking can be done by using several methods. It can be classified into three types. Number 1, plugging or reverse voltage braking. Number 2, regenerative braking. And finally, dynamic braking. Plugging of AC machine. Plugging induction motor braking is done by reversing the phase sequence of the motor. It can be achieved by interchanging connections of any two phases of stator with respect to supply terminals. Due to that, the direction of the rotating magnetic field is reversed with respect to the rotation of the rotor. During plugging, the slip plugging is equal to 2 minus S, where S is the original slip of the running motor. So from figure below, you can see that the supply terminals to the stator side is interchanged between red and yellow. Next, advantages and disadvantages of plugging. So the most obvious advantages of plugging is that it is the quickest way to stop the motor. This is because torque is developed in the opposite direction of the motor's rotation, which produces a strong braking effect. However, the disadvantages or drawback of using plugging. So during the plugging operation, very high I2R losses or copper losses occur in the form of heat. This heat is more than produced when rotor is normally locked. So we can't apply plugging frequently as due to high heat produced rotor which can damage or melt the rotor bars and even may overheat the stator as well. In simple words, when using plugging to brake the rotor, there are energy need to be released from the rotor that can be used as a regenerated power, but now the energy is being wasted in the winding resistance, which will generate significant heat. So example 6 will be discussed in the next video. Next, we move to the second types of braking by using regenerative braking. So by definition, this technique of braking uses the concept of energy recovery mechanism, which slows a vehicle or object by converting its kinetic energy, in this case the rotation of the motor, into a form which can be either used immediately or stored until needed, provided that you have some sort of battery to store the energy. So when the regenerative braking happens, the rotor speed exceeds the synchronous speed of the motor. So machine acts as an induction generator, returning energy to the supply. So because during this time, the motor have more energy and the energy will be returned to the supply or stored in a battery, the same concept as generator. And the last point, slip becomes negative because again, the rotor speed is faster than the synchronous speed. This is figure of the regenerative braking, you can see that two different energy exchange paths, which show either the machine act as a motor or as a generator. The green arrow show when the machine act as a motor. So energy is taken from the battery and will be supplied to the motor to rotate the transmission. At this time, the synchronous speed is faster than the rotor speed. While having the regeneration mode, will follow the red arrow. And now the red arrow is pointing upward. It means that now the rotor speed is faster than the synchronous speed. The energy will be returned to supply or battery, and now the machine acts as a generator. Finally, the third types of the braking is dynamic braking. In this case, we are looking into the technique of DC injection. The dynamic braking is achieved by disconnecting the stator winding from the AC supply and connecting it to the DC supply. So let's look at this figure. So in this figure show when we want to apply dynamic braking, the AC supply to the stator will be taken out by using the contactor. However, the AC supply will go through a set of diode circuit that act as a rectifier circuit, change the AC voltage to DC voltage, and will be connected to any two terminal of the stator through a current limiting resistor. So during dynamic braking, the stator magnetic field is stationary as it is fed from DC supply, and the rotor continues to rotate in this stationary field, but now the rotor will decelerate and finally stop. So slip for dynamic braking is 1 minus S.